957. Use the diagram of circle C at right to answer the questions below. Each part is a new problem. All right, so if we start with A, it says if the measure of x is 28 degrees. Okay, so this is 28 degrees. What is the measure of arc AD? Okay, so we want this arc out here. Okay, so we want this intercepted arc. So we have to, with the lesson that we did today, we know that this angle here has to be 90 degrees. That's not very good. Let me try that again. This has to be 90 degrees because it's intercepting the diameter, and this is 180 degrees, so this has to be half, which is 90. And then we have, this is 28 degrees, so this angle has to be 90 minus 28. Oopsie, that's 8, and so that's 2 and 62. So this angle right here is 60, well, let me try and do that again, is 62 degrees. And so then we know this arc, this is an inscribed angle, ABD is inscribed. So then this arc here has to be 2 times 62. So the measure of arc AD equals 2 times 62 degrees, which is going to be, what is that, 124? 124 degrees. Okay, and that is A. Alright, so now we're going to do B, and I'm going to erase all this stuff because it's a separate problem. Alright, so then B is if AD equals 5, okay, so this length here is 5, and if BD is 5 root 3, so this length here is 5 root 3, what is the area of circle C? Okay, so in this problem, we want the area of a circle, which is pi r squared. So I need the radius, and I know with this information, I know this is an inscribed angle. It's intercepting a diameter. So, and this is a right triangle. So to get this length would be the diameter. If I cut it in half, that would be the radius. So if I do 5 squared plus 5 root 3 squared equals AB squared, so that's 25 plus, and so this is going to be 25 times root 3 times root 3 is 3, so that's going to be I believe, let's see, 25 times 3 is 15, is 75, equals AB squared. So when you add this together, you get 100 equals AB squared, and so you take the square root of both sides, and so AB, the distance from A to B, is going to be 10. And this is the whole diameter. So the diameter, we don't want the diameter, we want the radius. And so the radius is going to equal 5. And so now I can plug it up in my formula up here. And so you're going to get 5 squared times pi, which is 25 pi. And it doesn't say anything about converting it to decimal, so I'm just going to leave it in exact form. So the area of circle C is 25 pi. Alright, so now we're looking at C. And C says the radius of circle C is 8. Okay, so if that's 8, then that means this length here is 8 and this length here is 8. And if arc BD is 100, okay, so this is 100 degrees, what is BD? Okay, so one of the things I see right away is if this arc here is 100 degrees, then I know this angle here is 50, right? Because the vertex is on the circle, it's got 2 chords, it's half of the intercepted arc. So then if I look at my diagram, kind of like what they have here, I'll just sketch what they have. This is 90, and so we know this is 50 degrees, and we know this is 16. And if I want to get what BD is, now I can use some trig, because I know this is the opposite side, and I know this is the opposite side, and I know this is the what is that, adjacent side, or no, opposite adjacent, yeah. Okay, and so then the cosine of 50 degrees equals BD, let me write that a little better, BD over 16. And so BD is going to equal 16 times cosine 50 degrees. And you would go ahead and multiply that out. I don't have a calculator with me right now, so you can take 16 times cosine 50, and that would give you the length of BD.